Hi, Dave Snyder here. It is September 9th, 2012, and I do believe I've got an accurate measurement of the moon from the prints on the Earth that it leaves on the Earth. Okay, I showed you in my other video this reversed image of the Copernicus crater over Northern California. Right, here's Copernicus Peak is right here somewhere, and this is Copernicus. Fits perfectly in here. You can watch the other video I made where I go through it in detail to show you that it goes there. Let me just show you how it fits there real quick. Just from above. What's up here? Okay. See the big circle in California right there? See this circle? That's a big impact circle that nobody notices, but it's right there. It is that crater that hits there. It absolutely is. Gone over it already. So what I did is I worked with this picture. I put a big picture of Copernicus right here, just full view, basically. And it looks small. The moon looks small in this picture, but it's because it's all stretched, squeezed together. It squeezes the two sides together as well, so makes it look small. But anyways, what I did is I measured, I looked at this one. This is Kepler right here, right? That Kepler crater, and I looked up there where it was in this picture. After I put Copernicus, it's just a rough. This is just sitting there roughly. I mean, and you can see how everything is in there actually. All the lines are in there, California and all across the United States. All those lines that shoot across like this, you see them all in the United States, North America. A lot of them. Okay, and then you see this little cut right there in the ocean. See that right there? Look, right there. And so what I did is I took the Kepler and I put it up there. There it is, and it's there. And it's not very. It's the moon images that they give us are a total joke. I know can do better than this. I know they can do better than this. This is not very good, really. I mean, but it'll work. It'll work. Okay, first look at this here. This shape right here where it cuts in. That goes right there. See how it narrows? It tapers inwards like this. It does the same thing right here. Just is like the last part of this area right here. It comes down right here and ends right at the crater basically. But the crater's there too. See the crater? All the craters are there. But see the crater right there? That's the crater. Okay, this one's there too. But I want to focus more on the one below it down here. This one down here. This one right here is obviously there. I mean, this one you can see the pattern. See the unique pattern inside. Okay, well let's take a look. Oh wait, where is that? Oh, same one. Look at the pattern on the Earth. Look at the crater. Look at the crater on the side over here too. Watch. And you can even see this curve that goes around the front. It's like blast pattern. See that? That's definitely there. That's guaranteed right there. I can see that. That is there. Okay, so what I did, that puts this in the correct spot. So what I did was I measured between those two distances, or the distance between these two objects here. Right in the middle of Kepler, and right to the middle of Copernicus. But what I did is I backed it up a little bit and rounded it off to 1,333, right? Because I noticed that's actually what it came to when I measured that. But then when I went to the moon to measure the distance between these two craters, it came to 333. I mean, I rounded it off to 333, so it would be 333 into, or multiply 333 times 4 gives you 300 or 1,332. It's one number off from being perfect. So I mean it's almost exactly 4 times the size that they say by looking at the prints on the Earth. 4 times the size. This would be 333 miles between here on the moon. So they say, but it's got to be the same as it is on the Earth. If it fits on the Earth right here, this fits on the Earth right here. It didn't grow that much. It couldn't have grown. Well, maybe it could have grown some, but I don't think that 4 times the size. I don't think it would have grown that much. Actually, probably wouldn't have grown it at all. So that tells us the moon's 4 times the size. Okay, let me just show you another way we can see that is by this impact crater right here. Mare Oriental. Hold on, let me find it real quick. Take a second. Right. This one. Okay, this overlay right here, this is of the Mare Oriental crater reversed over the Earth. And look at how it is Africa. It is absolutely Africa. Watch. It is all of Africa. Completely. And then you see Europe up there at the top. Europe. And the Mediterranean, it all fits in there just perfectly. It's the right size. Everything's the right size. You see this all over here. Right in the right place. It all fits beautifully. There's no way around that one. Here, weather patterns, just to show you that it fits. Look at the weather patterns, how they curve up like this right here. You see the same curve on the moon right there. See that? Same thing. There's not usually much weather here to show, so I mean, I'm just giving you what little I got there. But this crater right here on the Earth is, and it fits perfectly. It's 3,500 miles. That's what, 1,300 miles bigger than they say the moon is. Just that crater. That crater is bigger than what they say the moon is what I'm trying to tell you. And I fit it in more places than just this. This crater hits the Earth. There's no doubt about it. It hits the Earth. If these images are correct, like I always say, if the images are correct, if these photos that they give us of the moon, and if the Earth is all correct, then there's no doubt the moon hits the Earth. You can check it yourself. Like I said, you got what you got here is I've started the puzzle for you here. You can take Kepler and put it there, and you can take this here, and then you can find all the craters in between those two craters, and you can put them all in place in here like a puzzle, just like a puzzle. And I'll just let you do that because I've done it before, and I'll just let everybody else do it this time. If they want to know, that's all you got to do. Put Kepler up there, put this Copernicus here, and just put whatever's in between in place. You can download pictures of the craters off the internet. Reverse them. Make sure you flip them over before you overlay them onto the Earth. I'm sure you'll be able to find that. I'm sure you'll be able to find all of these. So, anyways, let's see the Copernicus full view again one more time. And you got to remember also, this is not the only impact that hits. This is Copernicus. This is the side of the moon that hits us now, right? The side of the moon that hits us now. Look at that. That's all one impact. The whole side of the moon that's dark like this is one impact. One impact. That whole dark side we see, one impact on the Earth. This has got to be the center of it right here. Basically, you can see it. It creates a circle. It's one impact on the Earth. One big giant kiss from a planet the same size as the Earth. It's got to be just about the same size, Mars size at least. But if you go, if it's 4 times what the size they say, if it's 2,100 miles across, that means it's 8,000, right? So, size of the Earth, same size, pretty much. It's 1,000 miles off, I guess. That's probably too long. 9,000. Thought it was 8. Yeah, it's more like it. Okay, so anyways, that's it. Just want to point that out. You can put the rest of the puzzle together, put all the other pieces in there. Go ahead. Let me know what you find. All right, have a good night, good day, good morning.